Okay, then we'll start. Good afternoon, everyone. I hope we are very well understanding about the sessions on various novel materials related to the biomaterials, composite materials, and also the materials that we use in biomedical field. Okay, so various other materials has been taught till now by various experts, speakers from NITs and IITs. We are going to hear many more sessions on the same theme called novel materials in further sessions. I will just cover the basic concepts of novel nanomaterials and its applications. And also we are going to deal about what are the various composites also. So myself, Dr. P.S. Rao, I am the program coordinator of this Atal program. I did my PhD from NIT Manipur. I have been working as a faculty since many years in this college, and from 2 years I have been working as an HOD. So that is my little introduction. So about myself. So now we will deal with we will be studying some. Yeah. So these are the contents that we are going to discuss. What are the composite materials? What are the types of composite materials? Introduction about the composite and classification of the composite materials and applications and advantages, and introduction of nano materials. We all know that the composite material, it is also called a composition material or a shortened composite, we can call it as. It is the material made from the two or more constant materials. It has got its own physical and chemical properties. If you combine any two materials of two different physical and chemical properties, then it produces a material with characteristics which is different from the individual components. The individual components remain separate and distinct within the finished structure, differentiating composites from mixtures and solid solution. So we know the composite materials are very stronger, and they are very light in weight and less expensive when compared to the conventional materials, means traditional materials. So that is the reason why they prefer these composites in buildings, construction in buildings, bridges and structures where we require high strength to weight ratio wherever it is required. So we try to use the composite materials, and nowadays in research areas we see the composite materials has got huge scope in research area. The best example for the composite is the mud building bricks that used in ancient times. Okay, so combining mud bricks and straws. So see how strong the brick will be. So this allowed the composite to have the strength and resistance of mud bricks and the tensile strength to grow. So you can see the example here, composition of composite fiber filament reinforcement, and this is the matrix, and this is how the composite will be made. Types of composite materials.
Sir,
composite materials.
Not moving, sir.
Huh?
Sir, your slides are not moving.
Are you able to see, sir, now?
Yes, sir. Yes, sir. Yes.
Yeah. Okay. Thank you.
You.
Yeah. So composite materials are divided into two: matrix type and reinforcement type. And then further they will be divided into polymatrix, polymeric matrix and metal matrix. You can see so much of research is going on in this metal matrix composites, aluminum series of alloys, copper series of alloys, and titanium and nickel, etc. And again in polymeric matrix, we can see thermoplastic, thermosettings, and matrix type we can say ceramic matrix, right? And from ceramic matrix, glass, alumina, and silicon carbon, etc. So then reinforcement means fiber reinforced structural, and fiber reinforced again continuous and short. So these are the various types of composites that we can see nowadays in the fields, right? So actually composites are also known as fiber reinforced polymer composites, because they are made from the polymer matrix that is reinforced with an engineered, man-made or natural fiber like glass, carbon or aramid or other reinforced. We will use the reinforcing material to make the metal matrix composites or ceramics, etc. So there are various composites we can see on the screen: laminar composite, fiber reinforced composite, and particulate composite, and composite of material that consists of two or more layers of different materials and bonded together. Okay, so we can see. So this is short fiber composite and filler composite, particulate composite, and these are the long fiber composites, and also this is flake composite.
Sir, sorry, sir. Sorry for the disturbance. Your slides are not moving, sir. First slide is showing, sir.
Oh. Okay.
Yes, sir. Now it is moving. Now it is okay, sir.
Okay, sir. There is some technical problem. If I put the PPT in slide mode, then actually the slides are not properly showing. So not moving further. So anyhow, so now you are able to see now, sir, screen.
Yes, sir. Yes, sir. Visible, sir.
Yeah. So now I am not going into slide mode. Just I will go by this mode only. Anyway, so yeah, composite materials we have seen that the types of composite materials. So the types of composite materials we have seen this one. Yeah. Classification of composite materials. Yeah, that is what we can see now. There are by reinforcement we can classify this one into fibers, viscous, laminar, flakes, filled, particulate, and microspheres. This is how we can classify the composite materials. So another types of composite material, those are protein based composites. We can call protein polysaccharide composite materials. No, they have been known a wide range of applications in the biomedical field. Just now only Ramesh also was discussing about these materials, right? So we use these materials in the field of biomedical engineering, and also in green chemical fields also we use. So these are the composites which have been fabricated into variety of forms such as films, fibers, particles, and gels, as per depending upon our necessary applications. So protein polysaccharide composite materials, they have many opportunities to improve the biological functions and technological functions. So currently these they are using They are fabricated from variety of proteins and polysaccharide sources. These are the complex materials which can be processed into variable shapes with unique properties for a multitude of applications, as I told. So these composites include silk, keratin, soy, and collagen, gelatin, resin, carnosine, and wheat gluten. Each protein can be distinguished by its mechanical, chemical, electrical, and optical properties, which allow for a broad range of applications. So currently, these applications that we can found in tissue generation, artificial tissue generation, and wound therapy, effective drug delivery systems, and food colloids have benefited from protein and polysaccharide composite materials. So huge application that we can see. So now we will see one by one fiber reinforced composites. What are the fibers are important class of reinforcement as they satisfy the desired conditions and transfer strength to the matrix constituent, influencing and enhancing their properties as desired. Okay. These laminar based composites are found in many combinations in the many number of materials. This composite will be made up of combination of the layers of materials bonding together. There may be several layers, more than two or many more materials. They are alternately or in determined order more than once and in as many as numbers of required for depending upon the specific application that we require. We will add this laminar composite layer by layer. Okay, that is how we will prepare the composite. Particulate reinforced composites we can see the microstructure of metal and ceramic composites. We show particles of one phase strewn in the other are known as particle reinforced composites. Square, triangular, and round shapes of reinforcements are known, but the dimensions of all their sides are observed to be more or less equal. The size and volume of the concentration of the dispersed distinguishes it from dispersion hardened materials. The flake composites, we will make the composites with flakes are often used in place of fibers as can be densely packed. So metal flakes that are in close contact with each other in polymer matrices can conduct electricity or heat, while mica flakes and glass can resist both. So flakes are not that much expensive to produce and usually cost lesser than the fibers. So we will make the composite with the help of flake and with the dispersion particles and also fiber reinforced. Right now, filled in composites. So fillers are used to make the fillers may be the main ingredient or an additional one in composites. So the filler particles may be irregular structures or have precise geometrical shapes like polyhedron, short fibers, spheres, etc. So we will use to make these filled composites. So what are the various factors that are affecting the properties of the composites? Okay, the type of the composite, distribution of the distribution of the fiber, reinforced or particle reinforced or plate reinforced, and also size, shape, orientation, and arrangement of the reinforcement will affect the properties of the composite material and it anisotropic. Yeah. So our objective is only to cover what are the various composites that we use. We can see the huge number of applications of these composites in various sectors, buildings, bridges, structures such as boat hulls and pool panels, racing car bodies, so bathtubs, storage tanks, granites, and cultured marble sinks, and also countertops. And not only that, even in aerospace also, aircraft, aerofoil surfaces, compressor plates, engine bay doors, right? So fan blades, rotor shafts, and turbine blades, turbine shafts, such as. In automobile sector also, it is got CNC cylinder, chassis, mudguards, door panels, dashboard, drive shaft, wind turbine blades. Sports, in sports sector also we can find the composite materials, like table tennis boards, slats, and gliding wings, spare tennis, badminton, fishing rods, golf. So huge number of applications that we see in various fields of engineering. Okay. So now, what are the various advantages of these composites? We can see light in weight, lower in density, high creep resistance, strength to weight and stiffness to weight are greater than steel or aluminum. Fatigue properties are much better than the common engineering materials. Composites cannot corrode like steel. It's because it's not a metal type. So, and ease of fabrication of large complex structure shapes. We can easily make complex structures, and we can easily incorporate sensors in the material to monitor and correct its performance. Smart composites, high resistant to impact damage, improved corrosion resistance. So we can see many mechanical properties are much better than the conventional methods. There are certain disadvantages we can call limitations. High cost of raw materials for fabrications are required. Composites are more brittle than wrought metals and thus are more easily damaged. And once damaged, it is difficult to attach also, and cost sometimes may increase. It can fluctuate. Sometimes it may be high and it may be low, and depending upon the material cost. And reuse and disposal sometimes may be difficult, and matrix is weak, therefore low toughness mechanical property. Okay. So, and difference between the smart materials and composite materials. Smart materials have multiple functions, right? Which generally include sensor, actuator, ability in addition to having form or being able to support at least some structural weight. Nickel titanium is the best example for this one, for smart material. After mechanical deformation, for example, bending, it can be heated up and will return to the pre-deformed structure shape. So composites are materials that are combination at least two or different materials which allow the engineering as desired properties like tailoring, mechanical stiffness, conductivity, classically about glass fiber composites. He just telling us the difference between the smart materials and composite materials. Yeah, nowadays there are natural composites are also becoming familiar nowadays in the research sector. Many people are using natural fibers or natural composites, right? Yeah. So they are natural fiber reinforced composites have become extremely popular for many users in recent years due to their good characteristics and ease in availability. Okay. Due to the government policies and also environmental concerns, the use of natural fiber in polymer composite increases day by day. So natural fibers have low density, high specific strength, and provide good thermal and acoustical insulation. So the natural fiber is derived either from plants, animals, etc. So these fibers have an edge over synthetic fibers in various sectors such as automobile, constructions, and sports industries, etc. So we can see what are the various plant composites, composite generated from the plant fiber, stalk, leaf, waste, and seed, fruit, and then animal fiber. Okay, so these are the sources from which we can derive the fiber composites. Yeah, actually now we will see some nanomaterials, and before that, then nanotechnology. What is that nanotechnology which has come into the existence? Okay, we all know we are all working in various engineering colleges, and also experts are from different fields. So nanotechnology, it has got enormous potential to change the society, and it involves manipulation of objects in the automatic level. One minute. So so the products will be built in every atom that are stronger, smarter, cheaper, cleaner, and more precise. So that is the reason why this nanotechnology has become so familiar. And so every matter can be manipulated at the size of 1/1 lakh, the width of a human hair, to create a new and unique materials and products, right? So it is basically roughly we can call it as a 1 to 100 nanometers, where unique phenomena enable novel applications. Okay. So a nanometer is nothing but 1 billion of a meter. That means we can imagine. So such size of, why nanotechnology? Why we prefer nano. At the nanoscale, the physical, chemical, and biological properties of materials differ in fundamental and valuable ways from the properties of individual atoms and molecules or bulk matters. So nanotechnology is directed toward understanding and creating improved materials, devices, and systems that exploit these new properties. So now, yeah. So there are various categories in the nanomaterials: one-dimensional nanomaterials, two-dimensional nanomaterials, and three-dimensional nanomaterials. Right. So in one-dimensional nanomaterials, the examples are given here. Right. Layers, multi-layers, thin films, platelets, and surface coatings. They have been developed and used for decades, particularly in the electronic industry. And in two-dimensional, we see nanowires, nanofibers made from a variety of elements other than carbon nanotubes, and a subset of this group, carbon nanotubes. Okay, then three-dimensional. In three-dimensional include precipitates like colloids and quantum dots, tiny particles of semiconductor materials, and nanocrystalline materials. So these are the various nanomaterials we see. In electronic industry, nanotransistors, nanodiodes, and organic light emitting diodes. These are all various nanomaterials. So application of nanotechnology that we can see in plasma displays and quantum computers. Now further we will discuss much about this thing. Yeah. So in life science also we see the applications of nanotechnology in targeted drug delivery, artificial retina, tissue regeneration, like that. So government is also investing lots of money in this field, because it has got huge impact on the in the technology. So there are so many states also, they are now trying to implement this technology. Now advantages of nanotechnology in medical, advantages are there. There are so many industrial advantages, right? So like for cancer treatment, heart disease, universal immunity, body sculpting, and these are on painless childbirth. And also industrial advantages: computers a billion times faster and million times smaller, and automatic pollution cleanup, and various other advantages are there. Of course, parallelly there are certain disadvantages. Actually, before along with the advantages, there are some disadvantages in the loss of jobs in manufacturing and farming. Okay, include because if the science and development is naturally, if it is increasing, then these traditional techniques and traditional conventional methods will be very less. So that is the reason why job scarcity may come up. But the technology wise, we can see the improvement. And also you will also find that development of nanotechnology can bring in crash of so many certain markets also, like use of these fossil fuels also will be very less if that is technology is developed, because they will become the nanotechnology will take over this sector also. Nanomaterials will be developed as an alternative sources of energy, and they will become more efficient. Therefore, we won't require the fossil fuels. Okay, and atomic weapons also can now be more accessible and made to be more powerful and more destructive. So this can become more accessible with nanotechnology. So since these particles are very, very small, as you know, in the terms of nanosize, so there can be problems arise from the inhalation of these minute particles, much like the problems a person gets from inhaling minute asbestos particles, right? So it is a very expensive technique, and developing it can cost you a lot of money. It is a pretty difficult to manufacture. Manufacturing cost is very, very high, and so that is the reason why we see the nanotechnology is a very expensive. But the technology, but we can have a use this one. Yeah. So you see, we are going to now cover various nanomaterials in the next slides. Okay. If you see the history, how the novel materials or novel nanomaterials has come. Take in 1959, come the principle of physics, as far as we can see, do not the word nanotechnology was first used by this Nairo Taniguchi in 1974. So, and in 1981, the technique that has come bottom up and top down. And then the term nano derives from the Greek word dwarf. A nanometer is a billionth of a meter. So, which we all know. I think you all know much about this one. That is historical background. And we see the various nano materials here. See, nanometers and all these things. So, what are the nanomaterials? Having at least one dimension in nanometer scale are called nanomaterials. Okay, nanotechnology is the understanding and control of matter at dimensions of roughly 1 to 100 nanometers, where unique phenomena enable novel application. Okay, so yeah. Particles are having sizes in the range of 1 to 100 nanometers are termed as nanoparticles, and the applications of nano-sized particles is what we call nanotechnology. Right. So there are specific nanomaterials. Physical, chemical, biological properties of material differ in fundamental and valuable ways. With reduction in size, the surface area of the materials and surface energy increases tremendously. Right. It requires expertise in physics, chemistry, material science, biology, and mechanical and electrical engineering, medicine, and their collective knowledge. When we develop any nanomaterial, we should have the knowledge. That is, it is a multidisciplinary course. So you see the types of nanostructures we can see here: clusters, nanotubes, and films and coats and polycrystals. These are various nanomaterials. Yeah, just the approaches of the nanomaterial synthesis: top-down approach and bottom-up approach. Okay, this is how this one. Bottom-up means making the small things into big size, and top-down means making big things into small nano size. So generally, a bulk material is taken and machined and modified to obtain required size and shape. The example of this approach is production of integrated circuits by etching or lithography process. Right? We see in the electronics sector. Okay. So top-down approach for nanomaterial synthesis, ball milling is used. Okay. For microcrystalline structures are broken down to nanocrystalline structures. Okay. Ball milling techniques we use. And bottom up, it is used to build the basic material. For example, assembling the materials from atom or molecules. The commonly used methods include sol gel, hydrothermal, physical and chemical vapor deposition, and epitaxial growth. Nanomaterials in nature. The nature is the best manufacturer of the nanomaterials and nanostructures. The nature by natural nanomaterials means the materials that belong to the natural world, like plant, animals, and mineral. Right. So without human modification or processing, due to their structures, they have remarkable properties because of their inherent nanostructure. butterflies. Okay, so very good example for this nano structures, right? And butterflies, you see how the structures are defined here. Yeah. See, see. So you see this one, fine microstructure, nano structure, and also nano structure. See the and right. So we can see the difference between fine microstructure and also nanostructure, the difference clearly. Nanomaterials in arts and cultural heritage, due to their presence of nano-sized particles of silver, gold, and copper up to 100 nanometer in size that were embedded in the glass. So light absorption and scattering by these nanoparticles determines the different colors. So applications of nanometals in paints also, incorporating nanoparticles in paints could improve their performance. It can impart various functional properties like self-cleaning, etc. So applications of nanomaterials in sunscreens and cosmetics also, they have become very familiar. The traditional chemical UV protection approach suffers from its poor long-term stability. Nano-sized titanium dioxide and zinc oxides are currently used in some sunscreens as they absorb and reflect ultraviolet rays. So transparent to visible light and so are more appealing to the consumer. So nano-sized iron oxide is present in some lipsticks as a pigment. So we use these nanomaterials in sunscreens and cosmetics field. Okay. So then also nanomaterials can be used for treatment, effluent treatment. So they are very efficient micro and macro photocatalyst. They degrade the toxic colorants and other organic bases. So application of nanomaterial in medical field also, we can see by delivering drugs to specific cells using nanoparticles. The overall drug consumption and side effects can be lowered significantly by depositing the agents in the morbid region only and in no higher dose than the needed. So nanomaterial is having a use application we can see in the field of medical. Okay, and also we can find the applications of the nanomaterials in sensor for gases. Sensors apply their sensitivity to changes in various parameters. They are designed to measure. They are designed to measure, and their measured parameters include electrical resistivity, chemical activity, magnetic permeability, thermal conductivity, and capacitance. Right. So you all know this one. And nanomaterials has a applications in energy field also. Solar cells, developing solar cells by multiple layers of different semiconductors in nanometric range. They are much more efficient than 20 years back to solar cells. No energy, that much of energy will be produced. They are acting as a better insulating materials also. These aerogens and nanocrystalline materials, okay, and yeah, they have got use applications in the. So they are used also in cutting tools, harder cutting tools and tougher cutting tools, nanomaterials. Okay, so cutting tools are made of nanocrystalline materials such as tungsten carbide, tantalum carbide, and titanium carbide are much harder, much more wear resistant, erosion resistant. So in all these fields, we can see the nanotechnology applications, nanomaterials applications. So high power magnets, to develop the high power magnets, to the magnetic power depends upon the specific surface area. So the magnets made of nanocrystalline grains possess very unusual magnetic properties due to their extremely large surface area. Okay. So and this thing. So we can see enhanced performance of the compound. The fatigue strength can be increased, and the fatigue strength increases with reduction in the grain size of the material. So by using nanomaterial, the fatigue strength can be increased by an average of 2. So this is how the we will see the applications of the nanomaterials in the medical field, automobile field, and aero space applications, and see even in cosmetics and other things. This is how the materials that we find, various materials, novel materials, means various materials of the composites, various materials of the nanomaterials, they are used in various applications. So this is just, I want to just, this basic things only, which you all know. I think you are not new to this one. You know all these things, but just to cover the basics only, I have taken this lecture. So not research oriented, but what are the applications of the novel materials in various field, and what are the various novel materials in composites, in nano sectors, etc. Just to cover that one only. So this is about my session. There are many things to learn from the experts. So again, we will come back at 3 o'clock. So till then, we will take a break. So with this, we end today's second session. Again, we will all join for the third session. Okay, at 3 o'clock. So if anybody wants to add, or if anybody wants to say something, or if anybody has any doubt regarding this session, please.
No, sir, clear. Thank you.
Okay, sir. Just to this is then these are only just basics only. Not I didn't go into much detail. Just to cover just the basics.